Let's look at something fun over here. I'm Mr. Ish. Thank you for joining me. We're looking here at alkene hydration and alcohol dehydration. Focus over here, alcohol. If you were to take this alcohol and hit it in concentrated sulfuric acid in high temperature, you can convert it, meaning you can dehydrate it into an alkene and water byproduct. If you take a look at this side, you have alkene and water, then you can hydrate it back to an alcohol in the presence of mild conditions, sulfuric acid and low temperature. You have two reactions here which are in essence equilibrium with one another, and you can see both of these come about in this video. I'll show you the mechanism by how this occurs. Let's look over here at the basic mechanism, starting with the hydration of an alkene to generate an alcohol. This is what we have. We have a compound. This is 1, 2, 3. You have a methyl here. You'll say it's 2-methyl. And then you can say 1, 2, 3 propene. You don't even have to say 1 propene. You can, but you don't have to. It's understood that the alkene carbons adopt the lowest numbers. 2-methyl propene is a good enough name. Now remember, the alkene hydration is occurring under mild conditions. So what are we going to see over here? We see over here a proton. How is this really coming about? Think of it this way. You are really looking at hydronium ions. That's what you have. Hydronium ion. Because you don't have the usual appearance of an oxygen where you have 2 pairs of lone electrons, but you have 1 pair lost to the development of a third oxygen hydrogen bond. It's charge deficient because you don't have the natural state of the oxygen with the 4 electrons. You have 2, hence it's charge deficient. You have the pi electron over here from your alkene double bond, in essence behaving as a nucleophile. This is behaving as a nucleophile, is going to attach that. Now you're going to do your addition here in the proper manner such that you develop a carbocation that's stabilized better, tertiary over a secondary over a primary. You look over here, you have a tertiary carbon here, you have a primary carbon here. You're going to put the carbocation here. The hydrogen will attach to the less substituted carbon, and when you do that, you see this. You have a CH3, you have your carbocation here, and your CH2 and your hydrogen. This hydrogen has attached over here, but I'll bring it here in the condensed format as you see. That's what we have. A tertiary carbocation has developed. This is the proper rules of addition. Now what do we see over here? You're seeing here a water molecule, and it looks something like this. You have here a water molecule that can behave in a nucleophilic manner. You can say it's a Lewis base. It's an electron pair donor in the sense that it's going to come over here. When it does, this is what you have. You have CH3, CH3, you have your CH3 here, and then you have your O and your hydrogen. You're basically a water molecule, and again, the development of the third bond using 1 pair of electrons will make this oxygen charge deficient. Keep in mind, we have to maintain everything in terms of balance. We're starting here with an acid. It's been used. We have to regenerate it by the end of this reaction. You will also remember your basic reaction is this, your alkene plus water to develop what? In the presence of acid, your alcohol, and you see all these items. I have my alkene, I have my water, I have my acid. The end result will be an alcohol. What will happen over here is the regeneration of the acid. Keep in mind, this is really called electrophilic hydration. It's electrophilic hydration of a double bond in alkene because you're using here an electrophile. This right here is an electrophile. You know it to be this. Here it's your electrophile, and it's hydrating an alkene. Hence this reaction is called a alkene hydration, but it's also electrophilic hydration. What you have over here is the regeneration of your acid and the development of your alcohol by a water molecule floating in your medium, and then it looks something like this. It's gonna use these to snatch this hydrogen. The electrons from this bond will go back to oxygen to regenerate the 2 electrons that were lost in the development of that bond. When you do that, you develop your alcohol. You have your alcohol first. I'll show that to you. That hydrogen has been snatched by water molecule, but you have in essence developed your alcohol plus your hydronium, which represents your regenerated acid. This right here along with this is your hydronium ion. Your acid has been regenerated, but this right here is your alcohol. How would you name this? Before we name it, keep in mind this step right here over here is also called deprotonation. Why is it called that? Because you're deprotonating your compound over here such that hydrogen is being pulled away. If you know this to be deprotonation, then this step right over here must also be called a protonation step. The protonation here, the protonation of your parent compound to start the process. And by virtue of what you see over here, then you can say that this right here would be your nucleophilic attack. So you're seeing three distinct processes coming here. You have a protonation, a nucleophilic attack, a deprotonation. But let's name this. You have your obvious 1, 2, 3 propane, but you have a methyl here on carbon 2 and you have a hydroxyl on carbon 2. You can say you have 2 hydroxyl, or you can say 2 hydroxy, and then you can say 2 methyl propane. Another way you can name this to bring the OL ending, the OL ending is this. You can say 2 methyl 2 propanol, and that would be a good way. 2 methyl 2 propanol, or 2 hydroxyl 2 methyl propane. Either way, I verbalized it, you can remember them both. The mechanism here is complete. This right here was your alkene hydration, which is also your electrophilic hydration. Now let's look at the dehydration of this alcohol back to the alkene. Now let's look here at the reverse procedure where we're going to dehydrate the alcohol. It's called alcohol dehydration to regenerate your alkene. And you know a water molecule has to come off. It's going to occur here in the presence of concentrated sulfuric acid in harsh conditions, meaning high temperature. How will this procedure start? You're looking here at a reaction medium which has protons. 2 of these electrons of the oxygen will attack that, and you will generate here protonated hydroxyl group. It looks something like this. 2 of these electrons will generate an oxygen-hydrogen bond, as you see, and it will make oxygen charge deficient because it should have 4 electrons, but now it has 2 because the other 2 are stuck here in that bond. What you see over here is the loss of this water molecule. These 2 electrons will come with the oxygen, and it will regenerate its lone pair of electrons. When that happens, you have a development here of a tertiary carbocation. Looking at over here, it's tertiary carbocation. The water molecule has been given off. These 2 electrons are going to re-supplement oxygen and bring it back to its natural state of 4 electrons. The water molecule has done its job and it'll go away. Now we're focusing over here. Look at this compound here in this better way. What you need to have now is the development of a alkene. And how can we develop that? You're looking at an acid which has been used. We can have here a water molecule which is basically floating around. It can use 2 of its electrons to attack that and regenerate the acid. When you regenerate acid, you're generating your hydronium ion, and you can say your acid has been regenerated and it's gone away. The water molecule is plucking only the hydrogen, but these 2 electrons right here, which are stuck in this bond, which I will represent now for you like this, will come over here and generate your alkene by creating a pi bond and fulfilling the deficiency in the covalence of this carbon. When you do that, your end result becomes evident. You have CH3, you have your CH3, and you have your alkene develop over here, and it's good. That is what we see. We have 2-methyl propene and the reaction is complete. The dehydration of alcohol will give you 2 products, one of which is water and one of it is your alkene right here. That's your dehydration. In the presence of harsh conditions, and your acid is naturally regenerated. This right here is the most important step for the students to understand. The water will pluck away that hydrogen, the 2 electrons of that CH2 hydrogen bond, which was the CH3. You know you have a CH3 over here, but I'm presenting that as CH2 and a hydrogen. That hydrogen will go away, the 2 electrons of this bond will go back here to generate your double bond. That brings us here to the end of the video.